Good day, sir. We're Einstein Group 21 and we are about to present lab experiment number 5. Our objective is to verify the principles that govern resistances which are connected in series.
In our apparatus or materials that we use to perform this lab activity is the PET Simulator Circuit Construction Kit DC. This builds circuits with batteries, resistors, light bulbs, and switches. As with the original version, students can drag wires, batteries, resistors, light bulbs, and switches to build a simple or more complex circuit. Simple learning goals use an ammeter and voltmeter to take readings in circuit. It provides reasoning to explain the measurements and relationships in circuits. Build circuit from schematic and determine if common objects are conductors or insulators.
Procedure. We will need 3 ammeters. For the first ammeter, it will read a current that flows through our resistance 1. Then, attach one resistor to our first ammeter. Connect our second ammeter to our first resistor. Then also attach the second resistor to it. Lastly, connect our third ammeter to our second resistor and attach also our third or the last resistor. We will now have 3 different values of our resistances. We now need to find the currents that passes our resistor, and at the same time, we need to measure the voltages in each of these. For the first resistor, we call it V1, the first voltage. Next, we put the second voltmeter in parallel, which is our V2. And then also put our last or third voltmeter, which is our V3. If we close the switch, we will now be able to measure both the current resistance in V1 and V2 and their corresponding voltages. For the total voltage of the circuit, we can probably attach the volt probe to the end wires of the 3 resistors. Now, this is how we connect series connected devices.
And now for the data. For the first trial, on our resistance 1, the value is 10, resistance 2 is 20, with a current of 0.40 ampere, and the current for the second one is 0.40 ampere, with a voltage 1 of 4 and a voltage 2 of 8, with a total voltage of 12. For the second trial, we have resistance 1 with a value of 20 and resistance 2 with a value of 40, with a current value of 0.20 in the first. In the second ammeter, we have 0.20 ampere, and also the voltage is in a value of 4 volts, and the second one is the value of 8 volts, again with a total of 12 volts. For the third trial, we have resistance 1 with a value of 30 ohm, and for resistance 2 with a value of 60 ohm, and for the ammeter 1 with a value of 0.13 amperes, and for the next current, we have 0.13 amperes, also with a volt value of 4, and the second volt with a value of 8 volts, and again with a total number of 12 volts.
For the computations, we have here the RT formula, which is RT is equals to the sum of R sub 1 and R sub 2. For the trials 1, 2, 3 on the table, we have there the values of RT provided, which is 30, 60, 90, respectively.
For today's lab experiment number 5, we have discussed about resistors in series. It is in a series circuit in which the output current of the first resistor flows into the input of the second resistor and so on. Therefore, the current is the same in each resistor. Because it flows in a parallel circuit, all resistor leads on one side of the resistors and they are connected together, which means that the resistance in each resistor simply add up. We also observe that because they are connected to each other, each resistor is very important in the flow of current. They are like the domino effect in which if one domino does not go with the flow, the rest of the dominoes will not work. And with this, we have come to analyze that each resistor is very important for it to work. That we must see that each resistor is working for the current to flow properly in one circuit.
For our conclusion, resistors that are connected in series is when they are DC chained together in a single line. To sum up our findings in the lab experiment, the total resistance of two resistors connected in series is the sum of the individual resistances of their resistors. When resistors are connected in series, and since all the current that flows through the first resistors has no other way to go, it must also pass through the second resistors and the third resistor, and so on. Then, resistors in series have a common current flowing through them, as the current that flows through one resistor must also flow through the other, as it can only take one path. Then, the amount of current that flows through a set of resistors in series will be same at all points in a series network. For the voltage, total of all the voltages across each component is equal to the voltage across the power supply.